Hello, my lovely algebra students. Hopefully by this point in time you have had a chance to look at this warm-up problem. Hopefully you can remember back to, I want to say, our third unit where we studied parabolas. Back in that unit we looked at the vertex form of a parabola, which is this equation, y equals a times the quantity x minus h squared plus k. Maybe you remember this, maybe you do not, but we want to know where is the vertex of this equation, y equals x minus 3 quantity squared plus 2. Maybe if you didn't remember before, your memory may have been jogged just now. Keep in mind, this is called vertex form, probably for a reason. Maybe you figured it out, but let's take a look at this problem. Well, if you recall, if we have our equation y equals a times x minus h squared plus k, h is the x-coordinate of our vertex and k is the y-coordinate of our vertex. So our vertex is the point 3, 2. Remember, this is the weird thing where it's the opposite of that number with the coefficient, but it is that number there on the outside. So we get our vertex point 3, 2. Remember the a value in front there, in this case it's just 1, but that a value determines the steepness of our graph. Is it skinny? Is it fat? And also tells us the opening of it. Does it open up? Does it open down? Is it happy? Is it sad? So we could draw a pretty quick sketch of this. We know the vertex is at an x value of 3 and a y value of 2, so it's right there. And since we know the coefficient in front is a 1, it should be opening up, and we can draw a little sketch just like that. Not too detailed, but it gets the basic information down. So now at this point I'd like to explain to you briefly what the rest of this day is going to look like. I'm going to introduce to you the equation we will be using in this unit. Remember, we are studying conic sections. We're going to start today by looking at parabolas. Recall that we've talked about 4 different types of conic sections. We have parabolas, ellipses, circles, and hyperbolas. Today, we will start our exploration of parabolas. So I'm going to walk you through some guided notes. So I'm going to be drawing things on my iPad. I would like you to copy those notes down into your notebook, and I will be checking them for points on Monday. So please get them down. It's not going to be too many notes that I need you to take, but I'm going to give you a few basic notes that you need to move forward. We're going to talk about the equation, and then I'm going to show you a couple practice problems, and the rest of the time is going to be yours to work. So without further ado, let's get started. So please get out your notebook, find a clean page, and draw along with yours truly. Okie dokie, hopefully you have your notes out and are ready to go. So remember, we've talked already that the technical definition of a parabola is a set of points that are all the same distance from the focus as the directrix. And this doesn't make much sense without a diagram to accompany it. So go ahead and draw yourself a little set of axes, x and y. Draw yourself a nice little parabola hanging out somewhere in the middle there. And then go ahead and add the focus in the middle above your vertex. And then below that, go ahead and draw in your directrix. That kind of looks not very great. Hopefully you are better at drawing straight lines than I am, but it should be good enough for our purposes. So real quick, remember what this definition is saying. A set of points that are all the same distance from a focus as they are from a directrix. Now that blue line underneath our parabola is our directrix, and that orange dot directly above our vertex is the focus. Now, technically, what we're saying here is if I pick any random point on this parabola, let's say, for example, I choose this point right there. Now we're saying the distance from that green dot to that orange dot should be exactly the same as the distance from that green dot to our directrix straight down. Now, obviously, this is not to scale. That vertical line looks to be much larger than that green line. But that actually tells me if I wanted to clean this up a little bit, I need to make my parabola a little bit wider. And I can do that. It's really not that big of a deal. So let's try to make that a little bit wider. Maybe that'll make it look a little bit better. I don't know. Still kind of lopsided, but let's give it another shot. I pick this point right here, and I go straight down to my directrix, and then that distance to my focus, which I lost, but I will draw in again. Looks like maybe it should be somewhere up here. Those two distances should be exactly the same. If you remember that notation from geometry, where you put a single tick mark on both lines, that means they are congruent, meaning they are the same length. That's our definition. You should be able to put any point on here, and if you recall the program I created in GeoGebra to show you this, any point on there, you should get the same distance between that blue line and the same distance to that focus, the orange dot there. So at this point, I would like you to make a nice, big, clean drawing of a parabola. I would like you to put a focus in the middle, and I would like you to put a directrix beneath it. Now, I would like you to label these as well. So let's label that the directrix, and let's label our orange dot the focus, and let's also label our vertex of the parabola. Now, just like we had with vertex form of a parabola, we're still going to identify that vertex as h, comma, k. H being the x value of the vertex, k being the y value of the vertex. Now, here is a new piece of information for you. The distance from the vertex to your focus is called p. Now, if you think about the definition, if you choose a point, any point on your parabola, the distance from that point to the focus must be the same as the distance of that point, from that point to the directrix. So, if we draw a line straight down like that, that distance also has to be p, because those two lengths have to be exactly the same. Now this is going to be very useful for us, and we'll see why in a minute, because think about what we said. The focus is directly above the vertex. So if you know the coordinates of your vertex, and you know that p value, which you can find from an equation, you know where that focus is. Because the focus is going to have the same x value as the vertex, so that's still going to be h because it's directly above it, but the y value is going to be p units above k because it's directly above it by a distance of p, so we can label that k plus p. Now, this is something good to have in your notes, but I don't want you to get too worried about h, comma, k plus p and remembering all those variables. You should just know that the focus is directly above the vertex. So the x value will be the same, but the y value will increase by that value of p. Or if your parabola is a downward opening parabola, then you can think of p as a negative value. and then your focus will be p units down from k. But we will look at that in a moment. So for now, I think we should go ahead and talk about the actual equation of a parabola. So this, again, will be another piece of information that I would like you to get down in your notes right now. And actually, before you do that, there's one more thing I would like to say at this point. Remember that we said that directrix is a line. And notice it is horizontal. It is perpendicular to the vertical line running through the focus and the vertex. And since this parabola is opening up vertically, it means that that directrix has to be horizontal. Equation of a horizontal line should be in the form y equals something, some number, no x, nothing like that, no variables, just a number, because it is a consistent y value since it's a horizontal line. Now, just like we came up with a little expression for the focus, we can do the same thing for the directrix. Now, it's kind of the opposite. So if you look at our focus, the y value there was k plus p because we were p units above the y value of the vertex. Well, the directrix is p units below the vertex, the y value of the vertex. So it's going to be y equals k minus p. Again, I'm not so worried about you trying to memorize y equals k minus p. That's not going to do you any good. Just remember that you are p units below the y value of the vertex, so it'll just be y equals whatever your y value of the vertex is minus p. Not too bad. Okay, now time for the equation. All right, please jot down this equation. X minus h, quantity squared, equals 4 times p, hopefully you recognize that p, times the quantity y minus k. Now, first off, try to recognize the similarities between this and our vertex form equation. Notice in both we have the expression x minus h squared. That's convenient. Nothing new to have to remember. They both still have that k. H and k mean the same thing. It's still h is the x value of the vertex and k is the y value of the vertex. It's a little different. We have a negative k over there and a positive k there, but that's a small adjustment. And notice we've got this 4p out in front, which is a little different. But that p is quite literally the p we just talked about, the distance between your vertex and the focus, or equivalently, the distance between your vertex and the directrix. So let's take a look at how this will actually come into play. First off, I would like you to recognize that if our parabola is centered at the origin, i.e. the point 0, 0, whoa, that looks like a face, that's cool. If our parabola is centered at that origin, then the equation is going to get very simple, and it's just going to go to x squared equals 4p times y. Because k is going to go to 0, and h is going to go to 0. So keep that in mind. Those are going to be the cases you look at first. And they're going to get more complicated, obviously, as they always do. But not bad. It's just going to be changing where your parabola is centered, where your vertex is. Not too big of a deal. So let's look at an actual problem now. So now I would like you to take 3 minutes to work on this problem. I want you to write the equation and sketch the graph of the parabola with vertex at the origin and focus at the point 0, 2. Now I'd like you to follow these steps, or rather, I'll give you a tip. If you're feeling stuck, try to follow these steps. Number 1, I would start to sketch your graph. So plot your vertex at the point 0, 0, and plot your focus at the point 0, 2. Next, remember your facts. We know that P is defined as the distance between the vertex and your focus. So you can figure that out. After that, it's just a matter of substituting into your equation. You know h and you know k because h and k are the coordinates of your vertex, and your vertex is at the origin. And you can figure out your p-value, so you can write this equation pretty darn quickly. And step 4, when you're sketching your graph, make it totally complete. Don't forget to draw in that directrix as well. And remember, that is p units below your vertex. So take a couple minutes and see what you can't get. All right, let's go ahead and take a look at the solution to this problem. Notice how I've written my vertex and my focus. Get used to that. I'm going to continue to write it like that. I put a V in front of my vertex, and I put an F in front of my focus. I would by no means say that's a standard convention, but in my opinion, it's a very useful and simplistic way to keep this information organized. So feel free to adopt it, but I'm going to keep using it. So hopefully you know what I mean in the future. Let's draw ourselves a quick little sketch of this situation. I think that sketching these situations is a really good first step to solving them. So plot your vertex. We were told it's at the origin, so it's at the point 0, 0. Plot your focus. We were told that is at an x value of 0, which it has to be because it has to be directly above or below your vertex if it is a vertically opening parabola. And the y value is 2. So go up 2 and plot your focus right there. Now remember what we said. The directrix is going to be that same distance below your vertex. So since we had to go up 2 units to get our focus, we need to go down 2 units to plot our directrix. Now, at this point, we can pretty much just draw in our curve. And now, it doesn't have to be perfect, but, you know, try to make it as good as you can. Make it look as nice as you can. Remember that any point you choose, going back to our technical definition, those distances should be the same. So again, this tells me that I need my parabola to actually be a little bit wider, so maybe something more like that is more realistic. But again, for now, just try to make it look as good as you can. That, I think, looks a little bit better. It's still not perfect, but it's not too bad, so I'm cool with that. But now, we want to actually write that equation. So we're going to be substituting our values into that equation. Now remember, we said our vertex is at the origin, so h and k are both 0. So we're going to get x squared equals 4 times p. P is the distance between the vertex and the focus, which in this case is 2, times the quantity y minus k, but again k is 0. So we can simplify this to x squared equals 8y. We know the focus is at 0, 2, and we know the directrix is at y equals -2, and we have completely answered this question. Yay! Alright, so one more type of problem I want you to look at today. Given an equation, a quadratic equation, I want you to be able to sketch a graph and also tell me where is the focus and where is the directrix and also actually where is the vertex. But for now, just kidding, not for now. Just kidding again. What do I want to say to you? What do I want to say to you? I want to say this. Remember what our equation looks like. This should be our goal. Something that looks like that. Now, this almost looks like that, but there are a couple differences. So go ahead and get started if you think you know how to get started. But if you don't, take a look at this real quick. We want our x squared bit by itself on one side of the equal sign. We don't want any numbers, any coefficient out in front of it. We want the x squared bit on one side, and then we want the y bit and any coefficients to be on the other side of the equal sign. So if you look at this equation, notice our x squared term is on the right, but so is that coefficient. So you should be thinking, how do I move that coefficient, that negative 1/12, to the other side? And then once I've done that, how do I figure out my p-value? Because you need your p-value to know how far away your focus and your directrix are from the vertex. So those are the things you should be thinking about. 1, how do I get x squared by itself? 2, how do I find p? And then 3, once I find p, how do I use that p-value to identify the directrix and the focus? So as before, take about 3 minutes and try to work through this, and then Mr. Hazen will replay or continue the video for you, and I'll walk you through it. Alright, let's go ahead and take a look at this video real quick. And that's not what I meant to say. Sorry, it's 11 o'clock at night. Let's go ahead and take a look at this solution really quick. So remember what we said a moment ago. We would like to rearrange this equation so that it looks like, we would like to rearrange the red equation so that it looks like the blue equation. Now first off, recognize that y has nothing being added or subtracted from it, nor does x. So that tells me that h and k are both 0, meaning that my vertex is at the origin 0, 0. So that's a good piece of information to store away for later. But think about what we said first. We would like to get our x squared term all by itself on one side of the equal sign. Right now we have negative 1/12 times x squared. So how do you get rid of the multiplication by negative 1/12? Well, multiply by its reciprocal, which is negative 12. So if I multiply by negative 12 on both sides, I'm going to get negative 12 times y equals negative 12 times negative 1/12 times x squared. Now notice first off I have a double negative, so those are going to go away. And then I have a 12 in the numerator and a 12 in the denominator, so those two terms will eliminate each other. And I will just be left with x squared, which was what I wanted. So I have negative 12y equals x squared at this point. Remember what we said. Our equation looks like x squared equals 4p times y, since h and k are both 0. So we need to figure out what is p. Well, notice on the right side of this equation we have x squared, and on the left side of this equation we have x squared. So if we want to solve for p, just take a look at the two equations we have. We have negative 12y equals 4py. Well, I could divide by y on both sides, and then my y's are gone, and I'm left with negative 12 equals 4 times p. And now it's just a simple linear equation to solve for p. I have 4 times p, so I need to divide by 4 on both sides. Negative 12 divided by 4 is negative 3, and my 4's eliminate each other there, so I get p is negative 3. Now I want to sketch this graph. So to do that, first off, I'm going to make myself a little room. Alright, so I've kind of consolidated the important information that we have. Notice that all I've written is my vertex is at the origin, which we found from our equation. So I can go ahead and plot that point. And the only other piece of information I need, crazily enough, is that p-value, negative 3. So remember what we said. P is the distance between the vertex and the focus. It's also the distance between the vertex and the directrix. Now, jump back real quick. Remember our vertex form equation, y equals a times x minus h squared plus k. Remember what we said about that a value, that coefficient out in front. That determines the shape of our graph in terms of the steepness or the wideness. And it also determined whether our graph opened upwards or downwards. If that a value is positive, it would open up. If that a value is negative, it would open down. It works exactly the same way with this equation and our p-value. Since that p-value is negative, that tells me that my parabola is opening downwards. So if I take that p-value, negative 3, and I go to my vertex and go down 3 units, my focus should be right there. If I go 3 units in the opposite direction of my vertex, I should get my directrix line. And now, all I got to do is sketch it in. Boom. Done, just like that. And we had our equation, which I think I erased, but no, there it is. Negative 12y equals x squared. And our focus, we want to identify that point. The x value is going to be exactly the same, so that's still 0, and the y value is negative 3. And now we are completely done. That's the last problem I'm going to walk you through at this stage of the game. Mr. Hazen will now pass out your assignment for the period. What you do not finish will be your homework, but it will be problems just like this, although you will encounter problems where the origin is not where your vertex is. So you will have h and k values that you need to figure out. And you might need to get clever sometimes with how you factor problems, but you all are brilliant mathematicians, and you can definitely figure it out. So be smart, be terrific, get this work done so you don't have much to do over the weekend, and I will see you on Monday. As stated, you have the remainder of the time in class to work on your homework. What you do not finish in class is due on Monday, but you should get a pretty good chunk of it done right now. I would like you to do problems 1 through 6, 7, 8, 12, 14, 16, 18, 22, 24, 25, and 27. Please circle those problems on your sheet so you can remember over the weekend which ones I would like you to do. They shouldn't take you too long. Work together, get it figured out. I'll see you on Monday, folks.